All right, so this is 3.3 / 3.4, part 2. So for the second half of these questions, we are going to be using what we learned yesterday with expanding and condensing to help us solve log equations. So today we're going to be solving. So we have some other properties here on how to solve. The first 4, so A, B, C, and D, are all 1-to-1. So if we have the same thing, so if 2 to the power of x is equal to 2 to the power of 5, our bases cancel. If we have the same base, we can cancel it out. We've done that before. If we have a log is equal to a log, they cancel. Same with an ln is equal to an ln, they cancel. And then same thing with D. The same base, you cancel them out and just set the exponents equal to each other. So these we've done before. E through H, so the second 4, I'll deal with the inverse property. So if our x is in the exponent, we would have to either take the log or the ln of both sides to get it out of the exponent. So here, if x is in the exponent, when our base is e, we want to take the ln of both sides of our equation, because what's the ln of e? It cancels. It's just 1. So this would be left with x, and it's equal to the ln of n. And then we would just put it in the calculator. If the x was in the ln, if we were taking the ln of x, I can make my big base e, so I can make it e to the power of ln, and that would cancel. So then I'd just be left with x is equal to e to the power of -3. So I make the big base e. If I'm taking the log of x, I can make my big base whatever my little base is here. So I could make my big base 10. So it'd be 10 to the power of log base 10, which cancels. And I could make my big base 10 here. So this would be x is equal to 10 to the power of -1. And then h is the same thing. Whatever my base is, I make my big base that. So 3 to the power of log base 3 cancels. So I'd be left with x is equal to 3 to the 4th power. Yes. So right below, we have strategies for solving exponential and log equations. So if we can, rewrite the original equation in a form that allows the use of the 1-to-1 properties of exponential or log functions. So the 1-to-1 properties are when you had like 3 to the power of x is equal to 3 squared, and then the bases cancel. So that x would be equal to 2. So if we can use the 1-to-1 properties, you can get it to look like that. If you can't, then rewrite the exponential equation in log form and apply the inverse property, or rewrite the log equation in exponential form and apply the inverse property. So let's look at A. My x is in the exponent, so how can I solve? I can take the ln of both sides. This would be ln of e and ln of 72. What's the ln of e? It cancels, so x is equal to the ln of 72, and then we just put it in our calculator. What is the ln of 72? 1.27? 4.27. Perfect. Perfect. 4.28. I think on the test it says 3 decimal places. It'll be specific. All right, for B. Before I want to use my properties, I want to get whatever the base that has the x in the exponent all by itself. So I'm going to divide by 3 on both sides to move that to the other side. So I have 2 to the power of x is equal to, what is 42 divided by 3? 14. And now how can I get that x from out of the exponent? Can I make 14 have a base of 2? No. What can I do? Yeah, I can put it in log form, or I can just take log base 2 of both sides. So log base 2 of 2 cancels, so I'm just left with x is equal to log base 2 of 14. Now we talked about this yesterday in the video. How do I solve log base 2 of 14? Perfect. Log of 14 over log of 2. So then we would have to do log of 14 divided by log of 2 in the calculator. What do we get? 3.81. So here again, we're solving an exponential equation. I want to get whatever my base is that has the exponent all by itself. So what should I do first? Add the 3 to the other side. So 4e to the power of 2x is equal to 5. Then what can I do? Divide by 4. So e to the power of 2x is equal to, what is 5 divided by 4? In the calculator. 0.25? 1.25. Now, how can I get that x from out of the exponent? I can take the ln of both sides. So ln of e cancels. So I'm just left with 2x is equal to the ln of 1.25. What's the ln of 1.25? 0.22. So 2x is equal to 0.22. Now how can I find what just x is equal to? Divide by 2. So what does x equal? 0.11. Awesome. All right, so let's look at example 4. What do you think I should do first to solve? Add 4, move it to the other side. So 2 times 3 to the power of 2t minus 5 is equal to 15. What can I do next? Divide by 2. So 3 to the power of 2t minus 5 is equal to 7.5. What can I do next? Awesome. Take the log base 3 of both sides. So log base 3 of 3 cancels, and I'm just left with 2t minus 5. And then how can I put the log base 3 of 7.5 in the calculator? Log of 7.5 divided by log of 3. What do we get when we put that in the calculator? 1.83. Now what can I do to solve for t? Add 5. So 2t is equal to 6.83. And then what? Divide by 2. So what does t equal? 3.42. All right, example 6, right below it. Here we're solving log equations. So how can I solve a? How can I get rid of that ln? I can make the big base e. So e to the power of ln cancels, so this would be 3x is equal to e squared. Whatever the base is of that log. So what is e squared? 7.39. So 3x is equal to 7.39. And then what's the last step? Divide by 3. So what does x equal? 2.46. Awesome. Any questions? All right, for B, how can I solve for x? Awesome. When I have a log is equal to a log with the same base, they just cancel. So now I have 5x minus 1 is equal to x plus 7. Then we just solve for x. So I can subtract x on both sides and add 1. So 4x is equal to 8. Divide by 4. X is equal to 2. All right, example 7. How can I solve for x? Subtract 5 on both sides because we want that ln all by itself. So 2 ln x is equal to -1. Divide by 2. So ln x is equal to negative, I'll say 0.5, -1/2. Now how can I get rid of that ln? Make the big base e. So e and ln cancel, so x is equal to e to the power of -0.5. What do you get when you put e to the power of -0.5 in your calculator? 0.61. Awesome. All right, let's look at example 8. How can I solve for x? Divide by 2, perfect, because we want to get that log all by itself first. So then I have log base 5 of 3x is equal to 2. Now what can I do? Make the big base 5. So 5 to the power of log base 5 cancels. So 3x is equal to 5 squared is 25. And then what's the last step? Divide by 3. So x is equal to 8.33. All right, let's look at 9. How can I solve for x? Condense, awesome. I like it when I have ln is equal to ln because then they'll cancel. But I have 2 ln's on one side, so I have to condense it. How can I condense it if I'm adding? Multiply. So this would be ln of x minus 2 times 2x minus 3 is equal to 2 ln x. Now, do I have an ln is equal to an ln? Almost. I have that 2 in the way. How can I move that 2? Where can I put it? Awesome. It's going to go on top of the x. So I'm condensing the right side too. So this would become x squared. Ln of x squared. Now I have just an ln is equal to an ln, so they cancel. So this would be x minus 2 times 2x minus 3 is equal to x squared. I have to FOIL, awesome. So I need to multiply out that left side in order to solve for x. So I'm going to FOIL. So this would be 2x squared minus 3x minus 4x plus 6 is equal to x squared. What's next? Combine like terms, and I can move that x squared to the other side. So I get x squared minus 7x plus 6 is equal to 0. how can I solve for x here? Factor it. Do I have two factors of 6 that add to -7? -1 and -6. So x minus 1 and x minus 6. Set them both equal to 0. So x minus 1 is equal to 0. X minus 6 is equal to 0. So x is equal to 1 and x is equal to 6. Now in the directions here, it says check for extraneous solutions. I can't take the ln of a negative number. So I always need to plug in my two answers and see if I end up taking the ln of a negative in the original question. So when I plug in 1, this would be ln of 1 minus 2, which is what? -1. What happens when you put the ln of -1 in your calculator? Error. So can 1 be a solution? No. So 1 is what we call an extraneous solution. It doesn't work. Now we can also check 6. So if I'm taking the ln of 6 minus 2, 6 minus 2 is 4, so that's a positive number, so we're good there. Here I have 2 times 6 minus 3, which would be 9. 9's a positive number, so that works. And then the ln of 6 is positive also, so that works. So 6 works. So x is equal to 6 is our only answer here.